All right, starting chapter 3.3, which is about increasing and decreasing functions and the first derivative test. Where we're going with this, chapter 3.3, 3.4, 3.5 are all about using derivatives to tell us something about the shape of a function. Sometimes you have information on the derivative of a function, like you know what the rate of change is, and you want to figure out what the original function, like the total amount so far is, and we can use some of the methods here. Before we start, we need to warn everybody about the most dangerous word in calculus. Any guesses about what it is, other than word problems? It is it. The dangerous part about it is not very specific. It is easy to confuse. So if we say things like, it is positive, what is positive? The original function, the derivative, or it is increasing. That's another dangerous one. Now, do you mean the original function is increasing, the derivative is increasing, maybe even the second derivative in later chapters? So it's important to be very specific, not just to communicate between you and someone else, but to communicate between you and yourself, to be very clear about whether you're talking about the derivative or the original function. So it is positive, it is increasing. Be careful about which you're saying, the original function or the derivative. Sometimes in my in-person classes I say, if you catch me saying it in an incorrect place, you should fine me $1 million or something, but no one has ever taken me up on it. All right. With that warning, let's give the book's definition of an increasing function. So an increasing function so we'd say if f of a is strictly less than f of b when a is strictly less than b, and notice that that means that we're going from left to right. So a might be like -9 and b might be +9 million or something. So by default we're thinking from left to right. Now I wish I knew what happens in cultures where their writing goes from right to left. Do they think about things the other way? By default, I wish someone would send me on a multinational tour so I can learn about math in all these other countries. But anyway, so if f of a is less than f of b when a is less than b, for all pairs a and b, so we're thinking of a and b here as x values, locations along the horizontal axis, in some interval, then we say the function is increasing on that interval. And if we say a function is increasing on that interval, then that means that f of a is less than f of b whenever a is less than b. So what are some common increasing functions? Just to get a feel for it. How about e to the x? Sketch in your mind what that looks like before I draw it. Ready? E to the x looks something like that. X cubed, you probably have a good picture of that already. Can you say cubics are increasing? Well, x cubed is increasing, but some cubics have a wobble to them and decrease in the middle, so you can't say all cubics are increasing. How about natural log? Draw that in your head or on your paper before you watch me draw it. Ready? So it goes like this. It goes to infinity there and to minus infinity there. Square root of x is another increasing function. Okay, so those are some common increasing functions. How about one over x, and we'll just deal with x greater than 0. If you remember, it looks like that. So as you get closer and closer to the y-axis, it shoots up toward infinity. So is that an increasing function? Well, if we pick an a and a b here, and here's f of a and f of b, is it true that f of a is less than f of b when a is to the left of b? Nope, it's the opposite. So the tricky part here is the function is increasing if you go from right to left, but the definition of increasing is from left to right. So even though I drew that arrow there showing it goes to infinity, which sounds like it's increasing as you move to the left. So it does not count as an increasing function. So in fact, this is a decreasing function. So f of a is bigger than f of b when a is less than b. So the function is decreasing. So here we're saying just for x greater than 0. If we did x less than 0, we would see a hyperbola like that, which would also be decreasing. But we were really only analyzing the one side of it. Okay, so just to re-emphasize, increasing and decreasing both default to being from left to right. You can say this function is increasing from right to left, but then at least you're specifying what direction you're doing, even though it's not the default. Okay, so that's a definition and several reminders. So increasing and decreasing default from left to right. Let's draw something quick here. Let's say this is the world's best parabola. So you know it has that same trend in both directions as you move farther on out. Would you say that f is increasing on negative infinity to infinity? So is f increasing on the interval from negative infinity to positive infinity? And here I don't mean the ordered pair negative infinity to positive infinity like x of negative infinity, y of positive infinity. I mean starting at x equals negative infinity, roughly speaking, and going to x equals positive infinity. Would you say f is increasing? Well, f decreases until you get to 13 and then increases. So overall it's not purely increasing. So we'd say nope. Would you say f is decreasing on the interval negative infinity to infinity? Well, it decreases for part of it, but not the other part. So it's not purely decreasing. So we would also not say that f is decreasing on that interval. What can we say? Can we say f is increasing on what interval? I would say 13 to infinity. So from here on out, f is increasing. Similarly, what else could you write? F is decreasing on negative infinity, 13. And some people are picky about whether 13 is included in the interval of increasing or decreasing. I'm not going to worry about it too much. Some textbooks go one way, some go the other way. So if you're reading a book and it's really important, just read what the book says, like the way it defines things. So if we ask, is f increasing without saying an interval? The default interval is the entire real line from negative infinity to infinity. And the same thing with decreasing, of course. All right, so that's some of our notation and definitions and stuff.